So we were discussing about health. Okay, so let's just I want to explain you this thing with the help of this diagram. So this is a diagram in which we have two different chambers, है ना? In one chamber oxidation will go occur, and in another chamber reduction will occur. Okay, oxidation means the losing of electrons. Clearly, you just clearly can see in this that we have a proper circuit of the flow of electricity. In solids, the electricity flow through the electrons, through wire. But in solution, or when we talk about cell, the electricity will conduct through the ions. That is what make our circuit complete. All right. So as you can see, we have two different chambers. One is oxidation chamber, another one is reduction chamber. Clear? So in previous class, we have studied about anode and cathode. So I have already explained you this thing, that on anode oxidation occur, on cathode reduction will occur. Clear? Your anode will connect it to the positive terminal of the battery, and cathode will connect to the negative terminal of the battery. Okay, so what happens, sometimes we used to just just do reduction and oxidation. What happened when we just switch on the key? मैंने इसको पूरा बैटरी से connect कर लिया. I have a complete circuit, anode, cathode. Along with that, I have a electrolyte. Electrolyte means the solution which we have inside the chamber. This is known as electrolyte. Why electrolyte word is used? In 10th class, I think you have studied about it in electrolysis process. Because in electrolyte, what happened when electricity fires, your ion get dissociate and they start moving. Ions जब टूट जाएंगे हमारे electrolyte के, तो क्या होगा? They will start move from one end to another end. As you can see through the salt bridge, the ions are moving. K positive ions are moving from oxidation chamber to reduction chamber, and your any NO3 positive and negative ions are moving from the reduction chamber to the oxidation chamber. Okay, so electrolytes are specific ionic compounds which can dissociate and form ions. ठीक है, सिर्फ हम यहाँ ionic compounds को ही लेंगे. This is the specific need of your electrolysis process. Why? Because if you take some other compounds, so they will not get dissociate in the presence of electricity. Clear? So electrolyte should be specific. Okay, next is the salt bridge. Salt bridge, what is a bridge? What is the meaning of bridge? Bridge is used to connect two points, है ना, through which things can pass from one end to another end. Bridge का काम क्या होता है? दो ends को connect करना. अब हम bridge को cross करके एक जगह से दूसरी जगह से easily जा सकते हैं. So that is why this is known as salt bridge. Salt means this is a composition of KNO3 means substance in aqueous form, and we just connect both our chamber with this bridge, and through this bridge your exchange of ion will take place. अगर ये salt bridge यहाँ नहीं होगा, then what will happen? Ion will not be exchanged from one chamber to another chamber. So to connect both the chambers or to make our circuit complete, we need a medium through which we can transfer ion from one oxidation chamber to reduction chamber, and from reduction chamber to oxidation chamber. Clear? So this is known as salt bridge. Okay. Next, last but not the least, battery or your bulb, so that we can see a connection. How will we see that your circuit is complete? Because of this bulb. When you turn on the key, your bulb will glow out, and it just shows that your circuit is complete, and your ion means particles are moving from one end to another end, electrons are moving from the one end to another end. In solids, the electricity is moved through electrons. In liquids, the electricity passes from one end to another end with the ions. Okay? This is a basic question. This type of question you can get in your objectives. So that is why metals are considered to be as good conductor of electricity, because they have free electrons, but ionic compounds are considered to be as the good conductor of electricity in molten state or in dissolved state. Now we have listened that theory. हमने movies में भी सुना, 3 Idiot movie का best concept. What was that? Salt water is the best conductor of electricity. Why? Because That salt water contain NaCl, sodium chloride. Sodium Na positive and chloride is Cl negative. So what happened when you mix the NaCl in water? It gets disappear within seconds. So what happened? Ions of NaCl get dissociate and which are responsible for flow of electricity in that liquid state. कभी ऐसा देखा है कि भाई हमने we have a means like means a bunch of NaCl, हमने छोटा सा a pinch of NaCl लिया और उसमें हम दोनों बैटरी के वायर्स को कनेक्ट करेंगे. Will your circuit will be completed? Will the electricity will pass through it? No, na. It will only pass when your NaCl comes in aqueous state. Aqueous state is dissolved state. Clear? Okay. Let's just continue with the voltaic cell and understand that how this reaction takes place, how your cells and batteries work. Because nowadays we are using a number of cells. For example, large inverter batteries, car batteries, they are large cells. They are like a series of cells are used in that. We used to see 2 points, one positive and one negative. A part of that we have medium sized normal cells which we used to use in torch lights. And next is small size cells which we use to in watches and remote cells. And also one important smallest type of cell is button cell, which we used to use in watches, in hand wrist watches. And so we have different categories of cells and how they work, how the electricity form, how the exchange of ion takes place, we will understand when we'll go down to the chapter. So let's continue with, for now, anode, cathode, electrolyte, your electricity, your wire, each and everything. Okay, let us continue with this one now. So redox reactions and electrode process. So what happened? These reactions are known as redox couples. Why couple? Couple is when we have two things, two different things actually. Not same type, we have two different things that makes a couple, or sometimes of same type make a couple. Agar different honge, so they will combine together and just perform a reaction in a different way. If they are of same time, they will perform a reaction in different way. Clear? So redox reaction and electrode process. So let us talk about redox couple. It is defined as having together the oxidized and reduced form of a substance, taking apart in an oxidation and reduction half cell reaction. So what happened when we have two form of substance? One is oxidized and one is reduced form. And if we are taking just in a reaction to perform our experiment, so what happened? These are known as the redox couples. This is represented by separating the oxidized form from the reduced form by vertical lines showing a solid liquid interference. So sometimes we can just separate out both the phases in solid liquid interference. What happened? In some reactions, your both the reduction phase and oxidation phase get separated. One will come into precipitate form and one will remain into the solution form, or you can say dissolved form. So sometimes it becomes easy to separate them. Sometimes we require different processes to separate them out of each other. So that is why at that point of time, at the point of like to explain the two phases, we used to write slash. We used to mention slash over there. Just example. Let me just show you how. For example, I have zinc 2 positive and Zn. Cu2 positive and Cu. So what happened? Your Zn, we have two state of Zn here. One is in two positive state and one is in solid form. Means like simple sort Zn, zinc. One is in two positive states of copper and second one is in simple copper form. So in both the cases, the oxidized form is put before the reduced form. So every time, whenever you form, write these equation, there is a rule. You must have to put the oxidized form before the reduced form. Let's start with the Daniell cell. Now we put the beaker containing copper sulfate solution and the beaker containing zinc sulfate solution side by side. So since I have just told you about the chambers, So in one chamber, we have copper sulfate solution. In another chamber, we have zinc sulfate solution. We connect solution in two beakers by a salt bridge or a U tube containing solution of potassium chloride or ammonium nitrate, usually solidified by boiling agar-agar and later cooling to a jelly-like substance. Note it down. This is the composition of your salt bridge. Your salt bridge is prepared by combining, means it contains potassium chloride or ammonium nitrite. It's usually solidified by boiling with agar-agar. Agar-agar is a compound and which literally convert that compound into a jelly-like substance. Okay, so salt bridge, what is the work of salt bridge? Salt bridge connect both the cells, your reduction cell and oxidation cell. Okay, this provides an electric contact between the two solutions without allowing to mix them each other. Since, as you have already seen in the previous diagram, what happened? The main function of the salt bridge is to connect both the chamber instead of mixing the solution. Salt bridge solutions को mix नहीं करेगा, but still it will connect. Okay, the zinc and copper rods are connected by metallic wire and a provision for an ammeter with a switch. So the outer circuit is your both the rods are connected by metallic wire. A part of that, ammeter and switch battery will be connected. The setup is known as Daniel cell. When the switch is in the O position, 0 position, no reaction will take place in either of the beakers. No current will pass through the metallic wire. Means agar aapka switch off hai, if you have switch in O position, generally we used to see na on some switches on, or you can see on small switches which we use in these types of circuit contain O and minus sign, O or 1 sign. That O sign means your switch is off, and that dash 1 whatever you see there on the opposite side, if that side is on, it means your circuit is on. So if circuit is off, your switch is off, that no reaction will take place since no current is passing or flow through the metallic wires. As soon as the switch is on, we get the following observation. Once you turn on the switch, we will observe so many things. First, the transfer of electron now does not takes place directly from the zinc to Cu2 positive, but through the metallic wire connecting the two rods, as it is parted from arrow which indicates the flow of current. Let me just show you with the help of diagram. As you can see, what happened when you turn on the key, the electrons will start moving from this end to this one. The electron will not directly jumping. They're not jumping. हमने भाई switch on किया कि भाई यहाँ zinc से copper तक electron easily पहुंच गए. No. क्या होगा? The flow of electron will be start from one end to another end through metallic wire. All right. The electricity from the solution in one beaker to solution in another beaker flow by the migration of ion through that salt bridge. We know that the flow of current is possible only if there is a partial difference between the copper and zinc rod known as electrodes here. As you can see in diagram, what happened? Once you turn on the key, the electron will start moving from zinc, means from anode to cathode. And what happened? Your exchange of ion will take place through this salt bridge. See, Na positive ions are moving from here to here, and SO4 ions are moving from this chamber to this. So they are just making this solution, or they are just completing the circuit. And the main function of salt bridge is to connect both the chambers, and through this salt bridge your ions can move from one point to another point easily. Clear? Standard electrode potential. So we have just understand this thing, what are electrode, how your circuit complete in Daniel cell. Let's just come to the important point, standard electrode potential. So if we talk about the normal potential, what is the capability, the strength? है ना? And when this is associated with the electrode, so this is known as electrode potential. So the potential associated with each electrode is known as electrode potential. If the concentration of each species taking part in electrode reaction is unity, है ना? If we just take the concentration unity, unity means one. Now we are standardized the thing. We have proper concentration, that is one unity. We have specific temperature, we have specific pressure. So the temperature at which is 298 Kelvin. Your at pressure will be means like taking as 1 atm 1 atmospheric pressure. So at the specific condition, at the standard condition, the potential of an electrode is known as standard electron potential, which is denoted by E naught. If we talk about the cell potential, a single electrode potential, that is E. If we talk about standard electrode potential, that is known as E naught. So a negative E means the redox couple is stronger reducing agent than H positive to H2 couple. If your value, if the value of E comes in negative, it means that we have stronger reducing agent. If we got the value in positive, it means that your redox couple is weaker reducing agent. So the value, by knowing the value of E, which comes in positive and negative, we came to know about that that it is a stronger reducing agent or a weaker reducing agent. Clear?